jumpers.
That's 2 ties in 3 weeks, man. At least.
Is it? Okay, I'll dial it back a bit.
Yeah.
I don't know.
Well, actually, no, I want you to dial
me.
it up. Last time we had a show, you talked about wearing 2 ties simultaneously.
Oh, yeah, right. Yeah.
Yeah.
I'm never sure which way up is. Up is more ties.
Up is more ties. Anyway, hello, dearies. Welcome to Undersampled Radio, episode 77. We have an excellent show for you today because I'm in a very echoey room because I have been kicked out of my house.
Oh,
which is my normal recording studio these days. Actually, I have a pretty sweet command center that I set up for podcast recording at the office, but I have house guests and I am minimizing my time away from them. So I am at a conference center business room thing in the apartment building here in Austin, Texas.
Convenient. So you need a third studio. Studio 3.
It's getting out of control. What's on the wall behind me? Yes, modern art, I guess. Can't see it.
Those look kind of interesting. Is it? Are they cartoons?
Tune in on YouTube to see us. No, it's just I don't know, some writing, some scripted typography with some textural elements as well. It's a little dimpled. I'm going to stop talking about art, and we're going to do some news bullet points, and we're going to introduce our guest. So,
oh, goodness.
First thing on the list, Matt. Well, actually, Matt doesn't have any bullet points, so I'll go first. Oh, yeah, you can't upgrade from Ubuntu 16 to 18 with the old standard dist upgrade, which apparently isn't a thing. It's due release upgrade until July.
Right. Man. I didn't realize that.
Yeah.
Mind you, I've done do release upgrade before, and it didn't go well for me, and I've never done it since. So now I just
blast it away.
Yeah, I either just start a new one, or in some cases just leave them forever. So I do have a couple of instances that are still on 12. It's just probably pretty bad, right? Is that bad?
What are they running? Nothing. No critical infrastructure, I hope.
No, nothing like that. But
the seismic boats, autonomous seismic boats driving around in the North Atlantic on Ubuntu 12.
but that's I'd be surprised if they're even on 12. I mean,
yeah, that's true.
Okay,
don't get nasty. We're only 3 minutes into the episode.
No, not because of that's not any kind of commentary on IT in industry or anything. That's more just like, isn't that just how you run big important stuff? You lock it in and it never changes, isn't it? I mean, that's what NASA do, right? That's why everything runs on elastic bands and pipe cleaners in space. Fortran.
Yes.
But honestly, it does bring up a point though, and I bet Ramey's got some opinions on this too. Well, anyone who works with computers probably does, but he probably does more important things than we do. But like anything you want to do, if you want to do it properly, if let's say you release an app and you want other people to actually use it, then suddenly you've got. It's hard for people who haven't been through it to understand how much nonsense there is keeping something like that running on secure infrastructure that actually works and isn't horrendously glitchy or sort of vulnerable. It's basically a whole other job.
Isn't that why Microsoft is still a company?
Yeah, I suppose it is. But this sort of DevOps thing, like it's a real thing and it's awful.
Sure is.
Yeah.
I'm excited to announce that we have
You're welcome.
I'm excited to announce that Riddle Me This is back.
Yeah, I'm excited to hear that.
What is that, Scotch?
It is, yeah.
Okay. Yeah, so I heard when we were doing these things consistently, I heard several times that our riddles were too hard. So I came up with an easy one. I know. Audience, step up. If you don't get this one right, just quit listening to the show. Well, you probably already have. But anyway, So one more news bullet point here, which is there's a conference coming up.
Next week, the APG. That's the one you're talking about. Yeah.
Yep. And I just bring that up because there's an unsession happening during that event, and everyone refuses to tell me what is happening with the unsession. So A, what is the deal, Matt? And B, what the hell, man?
Well, the general idea is that it's just another session, but instead of being people reporting on research projects that are essentially over or have reached some kind of milestone, and they're like retrospectives, this is more of a looking forward thing. So the idea is we get however many people we get, let's say 40, 50, 80 people, I don't know, show up, and we want to talk about machine learning in geology, maybe with an industrial angle, but maybe not. Maybe it's all academics who come and they want to think about just the science problems. And we will shepherd multiple parallel conversations between these professionals and students and people that show, and try and glean some useful insights and forward-looking, not promises, but speculation about the near future. And
what are the deliverables?
The deliverables I'd like to see primarily a list, ranked, filtered list of the most interesting / tractable machine learning problems, or let's say scientific problems in geology that could be attacked with machine learning over the next kind of decade. So anyone who's looking for, a research project or funding or things that might be of value to the community or to industry, will have a kind of cheat sheet for problems that have been validated and known to be interesting or valuable. I'd love to also see a little bit of like curated or crowdsourced list of interesting data sets, libraries, things that people are doing, recent successes, and that kind of thing. But I'm most interested in that list of sort of pressing questions in geoscience machine learning. Yes.
Well, I'm excited to see the outcomes. I'll be there. Haranguing
Excellent.
You with ideas.
Good. There'll be lots of software underground folks there.
Cool.
But yeah, I'm into this idea of it being like parallel computing. Like instead, because a lot of academic discussion sessions are handing a microphone around and listening to one person at a time. But in this thing, if the room is full, we'll have 12 parallel conversations happening. So we can get a lot done in a short period of time. That's like, so we've got half a day with 12 tables. That's the same as having a discussion session 6 days long.
I suppose that's true.
By my, yeah.
Good.
Think of the value. So, it's a whole conference happening in one room, in one session.
That does sound amazing.
Yeah.
So, speaking of machine learning in the geosciences, our guest today is Dr. John Ramey. He is the principal data scientist at Novi Labs. Welcome to the show, Ramey.
Hey, thanks for having me.
So we have a couple notes in here about your various endeavors. One is one of my favies here in Austin, and that is Austin Deep Learning Meetup. What's that about?
So my background is stats. So to be honest, my buddy Pierce Spittler and we started that meetup. I was very skeptical about deep learning, and I think I still am skeptical about that meetup. Or about the tech, and I guess the meetup too. I read a book, it's just called Deep Learning by Goodfellow. And all of a sudden I went, wait a minute, there's actually some science to this. It actually has statistics as its fundamental, its foundation. And I was actually blown away by that. So this was in the early days of the meetup. I went, hey, actually there might be some real possibility here for me to personally explore. In the meantime, it blew up on us. We went from thinking the first meetup was going to be 5 members, 10 attendees, and all of a sudden our first meetup, I think we had 200 RSVPs, 150 RSVPs. I don't even know. It's probably not even right. But I just remember being blown away, going, "What is with this hype?" So the first talk I gave it was the title of the talk was "Deep Learning Demystifying the Hype," because the point of the meetup is to get away from the buzzwords. I got really pissed off last night. We had a meetup, and I walked into we're hosted by Capital Factory here in town, and I walked up and I said, "Hey, is the deep learning meetup here? I just want to make sure." He's like, "Oh, are you here for the blockchain meetup?" And I got really pissed off. Why did I get pissed off? Because I do not want to be associated with just buzzwords. You know what I mean?
Well,
and the guy had no idea why I was so pissed off, but I was nonetheless pissed off.
Did you
should do a whole meetup just on buzzwords? You know,
there was one next door. I mean, blockchain meetup next to the I don't know. Yeah, maybe.
So Austin Deep Learning Meetup really is awesome because each one of the talks is sort of about some applied thing, or at least, you know, I've tried this and succeeded or failed, but it really is concrete, taking really cool stuff that we've all read about in literature, or at least in the Twitterverse, and explaining it using examples.
Yeah,
so that's cool.
The early days of that meetup were, I don't know, we didn't really know what we were doing, and there's no implication that we know what we're doing now. I don't think we know what we're doing. But on the other hand, I think the talks are getting more and more interesting. I mean, over the last several months, we've had actually Graham twice. But we've had a lot of interesting talks where, like, we've encouraged the community to do something more than an ImageNet problem. So if you're not familiar, basically classifying, does this image have a cat or a dog in it or something like that? Do something more interesting than just image classification. And people are starting to come up with some pretty clever and creative things. So I've been overwhelmed recently with just volunteers to give talks. My personal project, I'm actually giving a talk, not really sure when, but I am actually image captioning celebrity Instagram and then tweeting it out, right? So I wanted kind of like an intermediate project that said, hey, you can do more than just classify cats and dogs. And I'm looking for the most controversial of all of the captions labeled to, say, Kanye or Kim Kardashian or something like that. So I'm like hoping my title of my talk is something like, "My Twitter bot thinks that Kim Kardashian looks like a camel." Like, you know, that would be a great talk title, and so that hopefully that thing goes Hacker News, Reddit popular.
What's the training data set look like? Are you training on realistic captions? Or are you training on snarky, sarcastic captions?
I am using the what is the data set called? It's the MS Coco data set.
Gotcha.
It's using the VGG19 model, and I'm just cutting off the head of doing some transfer learning with VGG19, and then using an LSTM model to train captions from the MS Coco data set. So nothing too fancy. I'm much more interested in the headline of calling Kim Kardashian a camel or something along those lines.
Yeah, I was hoping you could train it with like the captions you use are like from the National Enquirer or something like that.
Yeah, I think that might be a pretty interesting.
Mixed with National Geographic.
Yeah.
Then you'll get all your wildlife references.
You're golden. That's it. So we have some links in the show notes if you guys want to go check those out. We have links to Ramey's Twitter, LinkedIn, and blog. I didn't realize you had a blog.
Yeah. I started that several years ago, and over the last few months, I made a commitment to myself that I was going to make that into a real thing. Like I was going to release posts regularly, so at least once a month. So for the last 2 months, I've been able to do that. Really, I'd like to get that to a point to where it's weekly or bi-weekly. The focus
That's
there.
That's a lot of writing.
Yeah, it is a lot of writing, but I actually enjoy it. It helps me clarify my thoughts.
Cool. You should check out Matt's blog. He agilescientific.com. They have an amazingly wide variety of topics, and it's a very well-read blog, and it's a semi-well-written blog. So you should definitely read it. It's awesome, and it covers some of the topics that I think you and Novi are interested in. Do you want to? Oh wait, I was going to move on, but before I do, do you have a time series talk coming up at Austin Deep Learning?
A time series talk. That is a really good question, and that's actually one that I've tried to get people interested in, but unless it has anything to do with NLP, people don't really care about sequential models. The short answer is no. I would be very interested in one of those. So if you have something in mind, please volunteer, because I think there's some pretty cool stuff you can do with time series.
I think so too. I thought so long enough to study it for 7 years. So or related concepts. Anyway, cool. That sounds good. Now back to Novi Labs. What are you guys doing?
So Novi, N-O-V-I, it's like Novi, like as in Emacs only. But Emacs only as a company name didn't really work out. So like we said, okay, how about Novi, hence Novi Labs. Short of it is we are a bunch of machine learning data science folks, as well as software engineers who are learning this oil and gas world that's large and crazy and filled with a lot of technologies from, I don't know if they were studying the dinosaurs before they started to decay and like, the point being is that, you know, the technologies are ancient. What we do is we predict how much oil is going to come out of the ground primarily for unconventional horizontal wells in North America. We are a scrappy startup. We've been around for about 3 years, but our focus is on completions optimization. In particular, fracking solutions, how much proppant should be pumped into the ground, how much fluid should be pumped in the ground, how far should wells be spaced. A lot of questions around frac hits, a lot of questions around artificial lift, and a lot of terms that I'm throwing at you that I hardly understand myself, because oil and gas has a lot of terms that I'm still learning. But I've been there for
basically just a language.
It is a language, yes. Yeah.
That was invented in a time before time. Yeah, I think that's so. I wanted to get you on the show because I think you and Matt are working on some similar problems and have similar mindsets. Matt's background is in geo. Your background is in statistics and signals and data. Do you have anyone over there that knows anything about geology?
That is a good question, and the answer is no. Actually, that's not quite true. Our CEO, he worked for a large oil and gas company for several years. Right now, we were actually seeking a unicorn. And Graham, you and I have had this conversation before. I actually found a unicorn. Ooh. And he was European, and he was about to sign the dotted line. And his wife said, "Hey, we're going to move to Europe." And so the unicorn, oh, man, he's the one that got away. But
oh man,
yeah, like this was one where it wasn't just okay, you kind of align with where we're headed. No, it was like it would have been the perfect fit. Yeah. Unfortunately, he's going to be the one that got away.
Bummer.
But we don't have any geophysicists or geologists or petro anything at Novi currently.
Gotcha. Well, if you are interested in those types of things, get in touch with Ramey. You can find him on LinkedIn. You can find him on Twitter, whatever. Okay, so tell us more about, let's dive into the problem you're solving over there, and tell us more about how you are predicting, let's say, production from data. What data did you start with?
That's a good question. We try to keep it simple when we're actually answering these questions. There's 3 buckets. So basically there's public information, well header data. So like simple things like the name of the well, unique identifiers, latitude and longitude, all the boring stuff. Then there's the various completions data. Some of that's publicly available, some of it's not. Examples of things that are not publicly available would be, it depends on the state within the United States. some states require reporting on things like how much proppant was pumped into the ground and the like. But like things like clusters and stages, if you're familiar with that, those are not always reported to the public simply because they're not required. Some states are have many more requirements than others. Moving on from completion, beyond that would be geo, right? So I don't mean that to be, I mean, I know this is a machine learning for geosciences podcast, but for us, we're primarily focused on subsurface data. And in particular, what we end up doing is we end up ingesting interpretation models from oil and gas companies. So our customers are operators, large companies that I had never heard of, but no doubt you've heard of them before. You know, there's the ones that have gas stations, and those are the ones I knew about. And there's everybody else I had never heard of. So those are our customers, but ultimately we're ingesting interpretation models. We also receive well log data from our customers as well as seismic data. We do not utilize those latter two well enough right now. Our focus is on trying to characterize a well, both by its completion data and its subsurface data, best to predict short-term production and long-term production. So short-term in our world is 6 months to 2 years. So we can accurately predict oil production reliably so, especially depending on the basin, within 8 to 10% and some extreme cases. But we hover around about 15% within how much oil is going to come out of the ground 6 months out to 2 years. So long-term is more of we're using classic reservoir forecasting techniques, and we're taking our short-term predictions and we're forecasting them to EUR, 30 years, 50 years, or just end of life of a well. We're utilizing that. So one of the reasons I joined Novi a year and a half ago is we don't just predict how much oil is going to come out of the ground. And I'm focusing here on oil. We do a lot of work on gas and condensate and even water, predicting how much water is going to come out of the ground for operational reasons. But our focus is on, we have a piece of software, we call it economics, our economics application. And what we're doing is the way we say it is we're giving a crystal ball to an oil company. If they make various changes to their completion design for the upcoming year, this is going to be the ROI. So there's a lot of financial metrics that we expose to an oil company to say that if you increase the proppant being pumped into the ground from 1,000 pounds per foot to 1,500 pounds per foot, that's going to be more expensive because you're going to be, putting a lot of more sand into the ground, and then there's the operational cost of getting the sand to the well. But on the other hand, pumping more proppant into the ground generally yields a higher oil production. So therefore, there's going to be more revenue. So the question is, what is the biggest bang for the buck? And what we encountered very quickly is that some oil companies care about the next quarter, and some oil companies care about 10 years from now. And of course, that changes every few weeks, simply as the price of oil changes and a new CEO comes into a company or something like that.
Yeah, right. Interesting. So it sounds like then the predictions that your clients want are sort of pre-drill. It's like, if we go drill over here, if we put a pad there, if we go by land over here, what kind of returns are we expecting?
That's exactly right. Yeah,
right.
That's
okay.
Exactly
So
right.
it's an exploration tool essentially, and a sort of speculation and exploration tool.
Yeah, I would focus more on the speculation. I would say scenario, like a what if scenario. Right. In particular, the reason I say not exploration is because generally speaking, the wells that we're forecasting oil about are those that already have been permitted. There's actually a permit to say that it may not have been drilled yet, or it may be in the process of being drilled, but there's a permit on it. So the exploration part has already been done, specifically on the latitude and longitude. Of course, there's other questions like how deep should this go? What formation should you go through? Those questions are generally, we are giving guidance but our software does that a little bit. But we certainly do not focus on that.
Right.
Our goal is to empower mostly reservoir and completions teams, but we need our geological components of our models to be. We need to improve them. Right now, we're doing some fairly simplistic things. I can't go into too many details, but we have great improvements to be made. And so when we actually interview people, we're actually saying this is how we're doing it. We realize, there's improvements to be made. We've had a couple of geophysicists who've walked in and they're like licking their chops going, I really would like to tackle this problem because they do see improvement to be made.
And you guys are doing this with a desktop application, is it, or a web app, or
it's a
human beings? Oh, okay.
It's a web app, right? So if the customer is Graham's Oil Company, there will be a URL that says grahamsoilcompany.novilabs.com.
I see. That's pretty cool. So there's obviously I don't know which bits you're sort of cool talking about, but there's like a grand model, and then they can provide some of their own data, and there's a kind of transfer learning on their data so that it's sort of tweaked for them, or it's all based on their own stuff. Well, you said you're mixing public and proprietary data.
Yeah, that's a really good question. So to clarify, often it's more up to the customer. We have some customers who are based in, say, in North Dakota, where the reporting requirements are pretty stringent, and therefore the data is much better.
Okay.
Often what we have there is a basin-wide interpretation model for things like porosity and a variety of other things that will be basin-wide or nearly basin-wide. And so the completions data we can trust, and often the questions we're being asked are completions-based. So we're able to use every well or almost every well if they believe that their interpretation models are reliable outside their own purview, like where their wells are. The other areas of the country, there may be 10,000, 15,000 wells in a basin, but the questions that a customer have are very specific to their proprietary data. So what it ultimately means is that even though we have 15,000 wells, we have to narrow that data set down to 200 or 300 wells, which makes it pretty challenging to answer some of the questions. Fortunately, we've been able to make vast improvements there. And transfer learning, like you mentioned, that comes up a lot. Like, okay, even if we have to filter down to 300, is there some other way we can incorporate all of the other wells we've thrown out? How do we incorporate those into our models? So that comes up quite a bit.
How much interpretation goes on? I mean, how much in terms of selecting which wells to use? How much geoscience goes on?
That's a really good question, and I don't want to paint a picture of sophistication here. Is actually we are relying on expertise from that company, some customer. Generally speaking, it's how much uncertainty is in your interpretation model in a various part of the basin, and if there is if there's some measure of uncertainty that there's some area of the basin where there's much less uncertainty, we may truncate the focus of the basin down to that subset. Whereas in other basins, we will rely on the expertise of the oil and gas company to, if they, like I mentioned before with North Dakota, often the companies we worked with in North Dakota, there's a belief that their interpretation models are pretty good across the entire basin, and therefore those are reliable. So the designation of reliable and unreliable, that is something we typically leave to the customer, but also we're trying to increase our own chops there. We're trying to understand that better and better. So we are trying to bring in-house expertise to help us better make that delineation.
Gotcha. Yeah, I have a question in the show notes, which is snarky, but it kind of drives at a point that we talk about a lot here on the show, which is, do we need domain experts anymore? I mean, you have a unique take on this, in my opinion, so I'd like to hear what you have to say about this. Oh, here it goes. But I'm serious. I mean, how percentage wise or just gut feeling wise or whatever, how much domain expertise do you need to accomplish your task? And then more generally, data science.
Let me see it from a slightly different perspective rather than making some broad sweeping claim. I believe from what I'm seeing, coming in as know very little about oil and gas, know a little bit about data, that the first question I asked when I went to some major oil companies was, what do all these people do? Like you'll go to an oil company and you'll have, I will hear that there are 100,000 people who are focused on some problem. And my question is, why? I mean, I don't mean to be too reductionist, but it's simply like, how are all of these people working on the same problem? That's, to me, I don't understand. So let me add some concrete example there. I went to one oil company, and I was asking some questions about the interpretation with a lot of humility. Hey, I don't really understand this stuff. Can you help me better understand so we can make our models better? It was great. And I was talking to a completions engineer, actually. And that situation was not unique. It was very much of a, get the geo guy in here and let him export his interpretation. So it was very much like the geo guy was at the beck and call of the completions guy. And he said, well, I can fit you in 6 weeks to 8 weeks, and I'll get you the data you need. So, but my point is like, okay, so I asked the geophysicist, I believe he was geophysicist, what does he do? He's like, well, I spent about 10% of my time like tweaking a model I built several years ago. And I was like, well, what do you mean tweak? He said, there will be a study in an area of interest, and we will tweak our spatial model, subsurface spatial model, to better incorporate that information. I'm like, oh, okay, so like you're adding new features or adding new data? He's like, no. I'm literally tweaking the parameters to match the expectations of the company. My main point is, like, to come back to your original question, I was like, why can't we just automate that portion away? So like there are certain aspects of like you need somebody who knows whether this model is correct or not. But do you need 50,000, 100,000 people? I don't know the actual number. When I talk to executives, it's usually hyperbole. But but do you really need 50,000 people focused on that? Now, to come back to your original question, like I'm not going to say you don't need any, but I would start by saying you probably don't need 50,000. Could we somehow empower 500, 1,000 with algorithms, or just remove a lot of the junk in their way to ultimately to make the models predicting how much oil is coming out of the ground, to empower those a little bit better.
Matt, do you think that would solve the problem in the oil and gas business?
What, removing more humans, geoscience ones? I don't know. I think it's really in the shale plays, especially, are really interesting. I mean, I have not worked a lot of shale, but my impression is that the geoscience has been kind of shut out of the shale plays to a great extent, compared to what we would call conventional plays, like the North Sea and what have you, where the models are essentially completely driven, and almost all of the decisions are completely driven by geoscience. And I think that's, so it's interesting that, and there's lots of reasons for this, but it's interesting that when data science comes in, it also has a hard time bringing geoscience into that picture. Like, I don't believe that the geology has nothing to do with those plays, but the indications are that it doesn't matter too much if you don't know much about geology. Right? The empirical evidence suggests that you can largely ignore it and still make a lot of money. Obviously arguable whether that's the purpose of exploration, but Yeah, so I mean, I think I just, I don't know what that means. I just think it's quite interesting that this second wave, if you like, is of shale exploration, and by that I mean like the first wave I would say was also data driven, but it was Excel spreadsheet driven.
Yeah.
And this new wave is data driven, but it's actual data science and statistics.
Yeah. Well, it's still powered by spreadsheets, so let's
sure, there's the spreadsheets all the way down at some point, but I think there's been an awakening in the last 3 or 4 years that there are tools out there that are much better suited to this than bar charts in Excel.
So is there
a
percentage of recovery that will never occur without domain expertise? I mean, is there something you unlock that you can't unlock with statistics?
Yeah. I mean, look, I'm a geologist, right? So I gotta cling to the idea that the Earth is really complicated, and we know a lot about geology, and surely we can get an advantage that way. But
have you heard of this paper called "Machine Learning for the Geosciences" by Karpatny?
Yeah, it's good.
Yeah, so like that paper, there's one specific instance I think is relevant. When I found this paper, I viewed it as very relevant to what we do. So I was in a meeting one time explaining machine learning to a lot of reservoir engineers, and I think there were a couple of geologists in the room. And one person blurted out in the middle of my talk, while I was giving it like a high-level overview of machine learning, "Is this going to replace my job?" And very quickly, the conversation from there stems to it turns to physics versus AI models. This comes up all the time. And one of the reasons why I like the Karpatny paper is it says that rather than trying to dichotomize and say, hey, it's either or, it's trying to find a happy medium of the two. So like one way to say it is like from a statistical perspective, if you have enough data, whatever that means, and you have an objective function that is reliable, it still may, or the recommendation or that your model may not abide by the laws of physics. It may be close, but it may not fully. So like in one sense, what Karpatny argues, like one approach is to add constraints to objective function on a machine learning algorithm. But to be very clear, I don't know what those constraints should be. Like if I have this objective function I'm trying to optimize, I'm not a geologist. I need the input of somebody like yourself, Matt. So that's why I'm quick to say I don't think geologists go away, but because like we have seen instances where our models are, for 95% of the cases, are very, very accurate. And then there are these 5% of the cases where it doesn't make any damn sense. I mean, it's like even where I, like to an expert like yourself, you would ask the question, what is going on here? And I certainly can't answer the question. And so those often, you could classify them as data quality issues or whatever. But at the end of the day, no one knows what's going on with, like, why is there a data quality issue or a data sparsity issue? Those are questions that are very difficult for somebody like me to answer because I don't understand the geology well enough. So the Karpatny paper, why I really like it, is it talks about blending the two. And so like at Novi, when we're talking to data scientists, ideally we do have, we are bringing somebody on board who has at least some oil and gas knowledge, but hopefully they're either geophysics or petro in some way, have background, who have learned this data science thing. So we are not hiring people who are outside of that scope. We believe that you can marry those together. Now, at first we thought, oh crap, this is going to be a unicorn we're trying to find. That's going to be very expensive. And then as we started looking, we kept finding more and more people who really know this stuff. Some people were better than others at the data science. Some people were better than others at the subsurface, the geo. But then we're finding a happy medium where we think that there's an overlap enough that maybe people like yourself, Matt, have learned this data science thing and we're able to combine those two approaches. So I don't think it's an either or. I do think that as we move forward to the second wave, like you said, there is possibility to combine the two approaches as opposed to abandoning the expertise.
Yeah, right. No, absolutely. And the other thing I really like about that paper is that the authors do a really good job of sort of surveying all of the things that make doing data science and machine learning with the Earth really difficult, right? About the huge range of timescales, the huge range of spatial scales, the fact that things have fuzzy edges. It's nothing like learning on logs from your widget selling website. It's not that kind of data at all. And I think it just intuitively, I sort of hope, I guess, that cracking those problems, or if not cracking them, then at least optimizing them and solving them as well as we can solve them with better than human level performance is going to take domain knowledge. I mean, I think I say to people like that geologist that blurted out this concern for his or her job, my response is sort of, well, yeah, I think it might take your current job, like your current tasks, but I think it's going to change your job, and I don't think it changes your purpose, though. Right. And actually, I think if you look at a lot of people's workflows, their tasks, their day-to-day are not that well aligned with their purpose.
No,
they do
I agree with you.
A lot of mundane crap and a lot of not really knowing if they're on the right lines or not. And a lot of kind of guesswork and uncertainty, and just a lot of, I mean, they're just not, a lot of them just aren't that good with data and don't really know how to wield large amounts of data. They just do one well at a time and then go through everything like completely manually. I mean, literally, you may have seen this, but I mean, you go places like Calgary and Denver, there are people who use scissors to cut bits of their logs up and then stick them with sellotape in different places so that they can put their interpretation together. I mean, right? So there's some fear there, understandably, but I mean, these like people like yourselves and companies like Novi and data science can give these people amazing tools and superpowers that they've never experienced before and they don't know anything about. So, I mean, I think that's hugely exciting. I hope most people do. It's like, if you're going to cling on to your job, then yeah, your job, but that might be a problem.
Yeah, there's a certain aspect, like there's from a statistics perspective, there's the classic prediction problem, right? That's our bread and butter. But naturally what is happening is that, all right, we have this black box that people are starting to rely upon, and therefore questions can be asked. Assumptions that have been tribal, that even tribes within a large organization, people are starting to ask questions that they've never been able to ask before. Part of that is data, because we are getting data from a variety of places. We can start having a more global perspective and a global opinion on what is happening. As an example, one question that comes up a lot is in horizontals and in unconventionals is that you have this well bore that can be, it's typically 5,000 feet or 10,000 feet, maybe somewhere in between, but typically you see 5 or 10,000, and you have very strong opinions about what are the various efficiencies of how fluids and proppant and a variety of other things, how those flow. And at first, when I was first getting into this, I thought, okay, rely on the expert fully because I don't know what I'm doing, right? I was new to the area. And then very quickly, I realized that you talk to 5 different people, you get 7 different opinions on what is the efficiency flowing. And then once we started to have models that were reliable, we were able to answer that question for ourselves. And so we actually have been working with one customer who they've had strong opinions about, like, if you're in certain areas of either Texas or Oklahoma or Denver, like you said, this efficiency should be, some people will say it's 70%. The more proppant, like if you double your lateral in length, you will get a 70% bump in oil. and somebody will say, no, 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 it's 80%. No, 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 it's 90%, right? And we have been able to reliably say, well, you're both right, just depending on where you're looking. And so all of a sudden the conversation has changed. Like, oh, we don't have to argue over that anymore.
Right.
What's the next question to answer? So right now, Novi gets bombarded with all these questions because there is excitement, like you were voicing a moment ago. There is excitement about, well, how about we settle this other debate? And so it's made life interesting for us. And I think about John Tukey, the famous quote of a statistician who says, the fun thing about statistics is that you get to play in other people's sandbox or their backyard. And so for me, it's pretty fun because I'm learning a lot about oil and gas, and that's certainly not my training. But I feel like I know a little bit now. I've been doing this for quite a while now.
Yeah.
But it is fun to be able to answer oil and gas companies that, like, basically break the tie on debates that have been held for years, maybe decades.
Yeah.
So based on those considerations, tell our younger listening demographic what they should be studying in school. Should they focus more heavily on mathematics and modeling and data, or should they focus more heavily on some domain-specific problem?
I would say the most important thing you need to know how to do is to code, and to code really, really well. If that means going through mathematical modeling to learn MATLAB or EE type courses and learn MATLAB, if that means to go to more of a computer science type program and learn Python or the like, or to be more of a statistics breed and learn R, no matter what, you should master one of those. If you go into the industry, I would recommend either Python or R. But just because you master one, you should also be familiar with the others. Namely, if you master Python, you should be familiar with R and vice versa. In terms of what you should study, you should be familiar with you should increase breadth. So you should know a little bit about machine learning. And this is not meant to be negative in any sense. You should start with the Coursera type courses because you're going to increase breadth there. But I would move beyond Coursera very quickly and actually get a book, a reliable book, and start there. I'm not even speaking to coursework per se because I really don't know the answer to that question of like what courses you should take. I do know though, if you are, I do see a world where machine learning is very involved, and those are and the ability to code will be very important. Those are two things you should learn. I haven't mentioned statistics specifically. I would recommend learning more than a statistics 101 course. I used to be a grad student. I used to teach that course all the time. Effectively, you learn in a semester what you can do in one line of code.
Yeah.
Here's a t-test, and here's the p-value, and here's everything behind that p-value. You should learn more than that. So where to start, I would actually get a kind of a entry master's level book on statistical modeling, or a really good one I learned of recently is called Intro to Statistical Learning. It's basically machine learning from a statistics perspective. You're going to get a blend of, like, it's going to be more of this is what statisticians really do. So go beyond the elementary statistics courses. Pick up a book. I can't speak to all of the the coursework that somebody should take, but I do believe that coding and familiarity with machine learning and statistics would be very important.
Excellent. Well, I'm sure our listeners appreciate that. You know what time it is, don't you? Riddle me this time.
Oh, that's exciting. Oh, that's a shame. Well, all right.
I'm cutting you off. We're gonna have Ramey back on the show. The other questions that you have. However, I did prepare a maybe I won't say that. A simpler riddle me this than we've had in the past, and I wanted to make it statistical in nature because of this background. If you come up with the answer to this question in 0.5 seconds, Ramey. Don't answer it on air because we have our listeners submit their answers to us. Okay, so here's the question. You've got 3 computers with 2 DIMM slots for RAM each. Computer A has 2. You writing this down? Computer A has 2 sticks of DDR4 RAM. Computer 2 has 2 sticks of DDR3 RAM. And computer Roman numeral 3 has has 1 stick of DDR4 and 1 stick of DDR3. Okay, let's say you randomly select a computer, randomly select a stick of RAM, which turns out to be DDR4. What's the probability that the remaining stick of RAM in that same computer is DDR4? Yep. You got the answer, Matt? Matt didn't even need it. He's got it. So tune in next week for the answer to that puzzle, that not quite so easy statistical riddle. And we look forward to seeing you then. Ramey, what are you reading at the moment?
I typically I'm reading 3 books at one time. One fiction, one nonfiction, and one kind of like self-help. Fiction, I'm reading Siddhartha by Hermann Hesse. Nonfiction, I'm reading The First Tycoon about Cornelius Vanderbilt. That's a really good book. It won a Pulitzer Prize, and it's very long, it's thick, but it's very, very good. And then third book is The Effective Executive by Peter Drucker. Apparently he's some business management guru who's no longer with us, but this book has come widely recommended to me. So those 3.
Awesome. That's a lot. I wouldn't be able to keep all the streams straight in my head if I was reading 3 at the same time. How about you, Matt?
I am rereading a Tufty, Envisioning Information. We're doing the hackathon in Copenhagen. The theme is visualization. So I pulled that book off my shelf the other day I don't know, I was looking for a particular figure, but anyway, I started reading it. So they're very readable books. I'd forgotten just how erudite the guy is. So anyway, highly recommended. It's probably, I don't know, 6 or 7 years at least since I actually read one of them cover to cover.
Good deal. Hey, I forgot to mention that Xpero is doing a Women in Tech hackathon here in Austin on July 28th and 9th. So
okay, cool.
Machine learning as a product. So if you are a product person and or a machine learning person, please come code with us. It's going to be awesome.
It's just wall-to-wall events and fun things to do in Austin, isn't it?
Basically it is. Hey, look, I started a new book the other day. It's called Notes on a Foreign Country by Susie Hansen. It's a Pulitzer runner-up. And it is so far pretty fascinating read. This woman moved to...
Great. Lost ground. It was threatening to happen all the way through.
Yeah. Was he a still image to you for periods of time?
It seemed to be. And my other computer that's actually running the Undersampled radio account has been sort of flickering continuously. I think it's Graham's like dodgy feed. And he's always telling, I don't know if you're on Wi-Fi, but he's always telling people don't use Wi-Fi. And that's probably what he's doing. Anyway, I'm gonna assume that he's not coming back just yet.
Back.
Oh, he's back.
Sorry. The Wi-Fi lasted almost the whole show.
Yeah. Well, what are you doing now? You've turned into old New Orleans Graham.
Oh yeah, that's a photo from my old office.
God,
anyway,
those were the days.
Thanks for joining us on Undersampled Radio. Ramey, thanks for coming on the show.
Yeah, thank you very much.
We'll see everyone next time, right back here.
Bye, everyone.